We will go over the Math90 practice exam. First question, 8x minus 3, 2x plus 5, 1 plus 5x minus 2. First you want to multiply these, expand. And the thing that you have to be careful is that because of this negative sign here, that negative 3 has to be distributed, making both of these negative. Okay, so you have 8x minus 3 times 2. 3 times 2 is 6, so it's negative 6x. Negative 3 times 5 is negative 15. 1 plus 5 times x is 5x. 5 times negative 2 is negative 10. Now, since you're trying to solve for x, you want to move all the x's to one side and all the other numbers that does not have x to the other side. So I see that this term here, and this term here, and this term, these three terms have x in there. The other ones don't. So I'll move the ones with x onto the right side. And remember, whenever you move a term, the sign changes. So because this is plus 8x, when you move it to the other side, it becomes negative x, negative 8x. The negative 6x will become positive 8x. Same here. If I move the 1 to the left side, it will be negative 1. If I move the negative 10 to the left side, it will be plus 10. Okay, so we have negative 15 because the other two terms went away. And then minus 1, and then plus 10 on the left side. Also, you have 5x on the right side, but then you have minus 8x plus 6x. Now combine these numbers. Negative 15 minus 1 is negative 16. But then 10 minus 16 is negative 6. So this is negative 6. On this side you have 5 minus 8, which is negative 3. Negative 3 plus 3, negative 3 plus 6 would be positive 3. So you have positive 3x equals to negative 6. And then finally, if you divide both sides by 3, you end up with x equals to negative 2. So negative 2 is the answer. Now we could have instead moved all the x's to the left side. So in that case, it could have been 8x minus 6x minus 5x. And the negative 15 will go to the other side, and you get 1 minus 10 plus 15. And in this case, you're going to get negative 3x equal to positive 6. And you get the same answer that way too. So either way, you're going to get the same answer. Second question. You're trying to solve this formula for b. You're trying to solve the formula for b. So whatever that's attached to this b should go away. So I need this 1/2 to go away. I need this h to go away. I need this b to go away. And when you try to take things away, you should do it in the opposite order as where it's applied to this thing. So first, if you look at this capital B, you first add the small lowercase b, and then multiply by 1/2, and then multiply by h. So that's the way that these operations are applied. That's the order of operations, right? And just like when you put on your shoes, you first put on your socks, and then you put on your shoes. And then when you take off your shoes and socks, you have to take off your shoes first, and then take off your socks. It's the same thing. You want to do what was done the last to go away first. So when I explained we needed the h to go away first, so I divide both sides by h, and then h and h will cancel, and you have a over h, and you have 1/2 b plus lowercase b. Now you need this 1/2 to go away. And what cancels 1/2? If you multiply by 2, 1/2 goes away, because 1/2 and 2, when you multiply them, they go away. And finally, you have b plus lowercase b. And then you have 2a over h. And finally, you move the b to the other side, or you can also just subtract b. That's another way to put it. Minus b, and you get capital B equals to 2a over h minus b. That's the answer. Okay, now we have word problems. Your first word problem is a mixture problem. And when you think about the solution strength, so when you say 91%, what does this mean? That means this is like you have the water plus alcohol solutions, the entire solution, and the ratio between the entire solution and what's dissolved in there, which is the alcohol, is equal to 91%. Now, normally when you see percent, you really want to change this into 0.91. That's because percent means, per means divide, cent means 100, so you have 91 divided by 100, that's 0.91. So that's what this 91% means. Okay, the alcohol over the solution is your strength. Now, the formula that we're using is basically this. The strength is the alcohol over the solution. So we're going to use this as our foundational formula to figure out everything else. So let's delete everything. Let me erase everything. And what you want to do is you want to have a solution 1, solution 2, and then the mixture. And for each of these, you want to write down the strength and the alcohol inside there, and then the actual solution. Okay, so the first thing I see is that Asher purchases 1 liter container of 91% isopropyl alcohol solution. So what you have here is that the strength is 0.91 and the solution is 1. And he wants to add pure water to make a 70% solution. So your goal for your mixture is 70%. And I wrote down second solution, but I was thinking just mixing 2 solutions. But it says the second one is not a solution; it's just the water. What is the strength of pure water? Well, that's 0 because there's 0 alcohol content, right? And we don't know how much pure water should he add. So how much pure water, we're going to define this as our x. So this is the unknown value that we want to put in. Okay. Now you have the alcohol content. Well, see, you have this formula. You can multiply solution both sides and say strength times the solution is your alcohol. So this value is obtained by multiplying these two. So 1 times 0.91 is, of course, 0.91. And then you're mixing. Okay. Now, in mixture problems, what you have to know is that the percentages never add up. I mean, there's no way 0.91 plus 0 would be 0.70, right? But the contents that you mix adds up. So when you mix 2 things, the alcohol in the first fluid and the alcohol in the second fluid, they would add up, right? So if you add, it's 0.91. And also, if you have 1 liter of fluid 1 and X liter of water, if you add them, the final amount of fluid that you get would be 1 plus X. Okay, so we have this final line, and we complete the table. Once you complete the table, then you have to think about coming up with an equation. Things that you have to look for is there any of the numbers that I didn't make use of? It looks like I have the 70 and 91, it's all made use of. Another thing that you should do is see if you can set two things equal. In here, I think we already used that principle. If you add the alcohol, it's equal to this. 1 plus X, again, it's equal to 1 plus X. And then finally, what you can do in this question, you can use the fact that strength times solution is alcohol. You apply this formula on this last line. So let's see. Strength times solution, which is 0.70 times 1 plus X, should equal to the actual alcohol content. So we solve this and we're done. Okay. Now, if you actually divide 0.70 both sides, you're going to get 1.3. So solving this by subtracting 1 both sides will give you X equal to 0.3 liters. Now, it's important that in word problems, if the units are given, you have to use the common units. So this is your answer. This is a speed, distance, time problem, and the fundamental formula for that is speed is distance over time. And you have two other formulas coming from here. If you multiply t both sides, then speed times time gives you the distance. And also if you divide both sides by speed, then you get time equals to distance over speed. So you have these three formulas to work with. And what you want to do is you want to divide the entire problem into several sequences or stages and figure out the distance, time, and speed for each one of them. Okay, so let's read on. Benjamin commutes to work and back along the same route. On the way to work, he is able to travel at 45 miles per hour. On the way back, he hits rush hour traffic and can only travel at 30 miles per hour. And his commute home takes 20 minutes longer than his commute to work. How long in miles is Benjamin's one-way commute to work? Okay, so it looks like there are two stages. One is going to work, and the other is back home, going back home. Okay, so there are two stages in this problem, and for each of these stages I need to figure out speed and distance and time. And let's write down what we have. The speed going to work is 45 and coming back is 30. Oh, and there's one thing that you have to be careful about. See this miles per hour? In miles per hour, hour is the unit of time. But this 20 minutes here is given in minutes. And if you don't change this into the same unit, then your numbers will all be messed up. So make sure that you have common units before you start. So let's see, what is 20 minutes? Well, 1 minute is 1/60th of an hour, right? So 20 minutes would be 20/60 of an hour, which is like 1/3 of an hour. Which makes sense because if you have 60 minutes, which is an hour, and you divide it into 3, you get 20 minutes. So yeah, this is right. Okay, so 20 minutes should be changed to 1/3 hour. Okay, now let's look at the distance. Well, the question is, how long in miles is Benjamin's one-way commute to work? Yeah, that we don't know, right? So we don't know. Now, how about time? Time is, well, there is the unknown time that Benjamin takes to get to work. And also coming back, I don't know how long it's going to take. But what I do know is that it takes 20 minutes longer. So x plus 1/3 hours. Okay, remember 20 minutes should be changed to 1/3, so I do that. Okay, once you have that, now this blank spaces can be computed by doing speed times time is equal to distance. I like this formula more than the other ones because the other ones you require fractions, right? So I like to use this a lot. So I kind of like wait until the last minute to have this blank and then multiply, and that fills this. Okay, so x times 45, 45x is the distance, and then x plus 1/3 times 30, 30 times x plus 1/3 is again the distance. Alright, so once you fill the table, then look here to see if there's any number that you didn't make use of. We did make use of all the numbers. And then see if you can make anything same. Well, in this case, we know that the distance going to work and distance coming back home are the same. This is very typical when you have a problem that says, oh, somebody went to someplace, location A, and came back. In those type of problems, you can easily set the distance as equal, and that gives you the answer. Okay. All right. So we set these two equal because the distance to go to work and distance coming back should be the same. So we write down 45x should equal to 30x plus 1/3. Multiply this, and you get 30x plus 30 times 1/3. That's 10. 45x. Now subtract 30x both sides. So 45x minus 30x is equal to 10. 45 minus 30, that's 15. So 15x equals to 10, which says that x must be 10 over 15, which you can reduce. Both top and bottom can be divisible by divided by 5. Top and bottom is divisible by 5. 10 divided by 5 is 2. 15 divided by 5 is 3. So 2/3 hours is how long Benjamin takes to get to work. And to come back home, he requires 2/3 and another 1/3 hour to come home. Now you have to be careful because the question here is not about the hours, but how long in miles is Benjamin's one-way commute to work. So it's actually asking for this distance. How long is this distance? That's the question. So actual distance is 45 times the time, which is 2/3. And 45 is 15 times 3. So if you divide 45 by 3, you get 15. And times 2, and you get 30 miles as the final answer. Okay, you have 2 points, and you have to find the line equation, the equation for the line. When you're given 2 points, the formulas that you have to know are first the point slope form, y minus y1 equals to m x minus x1, and you can name this as x1 y1, and this one we can name it as x2 y2. You can also name it backwards, it will still give you the same answer. Okay, So we know what x1 is. X1 will be 2. You plug in 2 here. Y1 would be -1. You plug in -1 here. But we don't know the slope m. So what's the formula for the slope? Slope is change of y over change of x. You should really memorize the slope as change of y over change of x, because later on in calculus, this is the fundamental concept that you have to know. But what is change of y? If one value became another value, then it's the final value minus the initial value that measures the change. So for example, if you had $100 this week and next week you had $200, the change is 200 minus 100. So you do the final value minus the initial value. So you do final value of y and the initial value of y. You subtract the two, and that's your change of y. And final value of x, initial value of x, that's the change of x. Okay, let's actually calculate this. y2 is 1. y1 is -1, so you need to put a parenthesis. It's negative of -1. And then x2 is -4. x1 is 2. Negative of negative is positive, so you have +2. -4 minus 2, that's -6, which is -1/3. Okay. So that's your slope. And then we plug everything into the point slope form. Y minus y1 is -1. Your slope m, we just calculated it, it's -1/3. X minus, and then x1 is 2, so you subtract 2. And then we simplify. Y plus 1. We multiply this out, so it's -1/3 x. And then minus minus is positive, so it's +2/3. Now, sometimes the question says, write your answer in point slope form. Then you can just stop right here. But this question was asking for the slope-intercept form. Right? This is what we call the slope-intercept form. So we actually have to solve for y to complete this question. So this is what we call the point slope form. This is slope-intercept form, and the question is asking for a slope-intercept form. Okay, we're almost there. We just have to subtract 1 both sides, and you get y equals to -1/3 x. 2/3 minus 1. Well, 1 is 3 over 3, right? So if you do 2/3 minus 3 over 3, that's 2 minus 3 over 3. 2 minus 3 is -1, so it's -1/3. So that is the final answer. Okay, the question that we just solved gave us y equals to -1/3 x minus 1/3. And this second question, part B, said we should find the x-intercept and the y-intercept. Well, to get the x-intercept, what do? You set y equal to 0. To get the y-intercept, you need to set x equal to 0. You have to remember these in order to get the x-intercept and y-intercept. By the way, these two requirements are the same for any function. So if you're given any polynomial, any function whatsoever, if you want the x-intercept, you set y as 0. If you want the y-intercept, you set x equal to 0. So let's set y equal to 0. And if you have a fraction in an equation, you should try to get rid of the denominators by multiplying something. And there are other ways to solve this, but that's the easiest. So try to follow this principle. Anytime you have a fraction, multiply by the denominator or all the denominators so you can get rid of the fraction. Okay. So in this case, they're both 3, so I'm just going to multiply everything by 3 times 3. Now, if you multiply by 3, 3 times 0 is 0, so that doesn't change. 3 times 1/3, 1/3 and 3 cancel, so you just have -x. 3 times -1/3, again 1/3 and 3 cancels, and you get -1. Okay, see, 3, 1/3 times 3 is like 3 divided by 3. because when you multiply a number to a fraction, its number should be thought as a fraction like this, and top multiplies, bottom multiplies. So it's 3 over 3, and if you divide 3 by 3, that's 1, right? So that's why 3 times 1/3 gives you 1, and same thing here. Okay, and I would like to add an x both sides so that x equals to -1, and that's my x-intercept. Now, actually, the x-intercept is a point on the two-dimensional plane, right? You really need to write down the coordinates. So rather than saying that this is the answer, it's better if you say -1, 0. So whatever that line is, I know that here's -1, 0, and it passes through this one. Okay, I know that the slope is -1/3, so it's probably something like this, passing through -1. Okay, so that's the coordinate. That's the x-intercept. Let me not put box around here and put a box around here because that's part of the answer. Now let's plug in x equal to 0, y equals to -1/3 times 0 minus 1/3. 0 times anything is 0, so you just have -1/3. So that gives you y-intercept as 0, -1/3. When x is 0, y becomes -1/3, and that's a point on the y-axis. This point right here is 0, -1/3. Then we are asked to draw this graph, y equals to -1/3 of x minus 1/3. And of course, you can just make a table of x and y values and plot them. Plug in 0 and you get the value of -1/3. Plug in 1 and get another. But that's just time consuming, and since we already know that this is going to be a line, see, y equals to mx plus b will always give you a line. And if you do know that, you just need 2 points. And in our case, we already know the x-intercept being the -1, 0, and y-intercept somewhere here. So this is -1/3. So 0, -1/3 is this point here. The y-intercept is 0, -1/3. X-intercept is -1, 0. And since it's a straight line, we can just draw a straight line going through it. And that's the answer. And that's faster. Next question. Solve 3x squared plus 13x plus 10 using factoring. Okay, there are several ways to factor this. You can do this by trial and error. You have 3x squared, so one will be 3x, the other will be x. And then you have 10, so this times this will be 10. So you can try out every combination, like 1 and 10, and 10 and 1, 5 and 2, 2 and 5. You can do all these. And you may also try negatives. Well, I know that it's not going to be negative because everything is plus. In that case, it's simple. It's just it's only positive. So you could do this. But the more systematic way of doing this is to use what we call factor by grouping. So let me explain what that is. So first what you do is you multiply 3 and 10. So 3 times 10, which is 30. And once you get that number, you look for two numbers that multiply to 30 and two numbers that add to the middle number, which is 13. Now this is almost immediate. I see that 3 times 10 is 30 and 3 plus 10 is 13. So I see that one should be 10, the other should be 3. Or vice versa. You could also have chosen 3 and 10. It doesn't matter. At the end of the day, you're going to get the same answer in either way. Okay, so that's step 1, figuring out these two values a and b. Once you have that, what's step 2? Step 2 is split the middle number 13x as plus 10x plus 3x plus 10, just like that. So 10 plus 3 is 13, so 10x plus 3x is 13x. Once you split the left side like that, then you can do something called factor by grouping. You can group the first two, group the second two, and you try to factor as much as possible. So you have x and x, so you factor out an x. Now there is no common factor between 3 and 10, so we just leave it as 3x plus 10. Plus, you have this 3x plus 10. In this case, there is no common factor. If you don't have any common factor, just put a parenthesis. Now sometimes you have a minus here. If you have a as positive and b as negative, in that case, you also have to pull a minus sign out. Okay. But in our case, this is an easy example, comparably. Okay. Once you have factored by grouping, then what happens is the resulting formula will have a common factor. You see 3x plus 10 and 3x plus 10, right? So that could also be factored out. You factor 3x plus 10, what's left here? You have an x left, you have a 1 left, so this is what you get. And then finally, when you have factored it, well, you have two things multiplied to become 0. When does that happen? When either the first factor is 0, or if the second factor is 0. So you have two possibilities. This happens when x is negative 1. You subtract 1 off both sides. This is what you get. And this happens if you subtract 10 both sides. It's 3x equals to negative 10. Divide by 3, and you get x equals to negative 10 over 3. Okay. So those are the two answers. Now this time, you're asked to use the quadratic formula. So let's write down the quadratic formula first. I like to sing this one. X equals to negative b plus minus square root b squared minus 4ac all over 2a. Okay. So that's the formula for the solution of ax squared plus bx plus c equal to 0. And because this formula only applies to this form, you first have to change this equation into this form. So let's do that. X squared plus 2. Let's FOIL this one first. 3x times x is 3x squared. So FOIL is first, outer, inner, last. So first, outer, 3x times 3 is 9x. Inner, 1 times x. And then 1 times 3. Okay. And then you have x squared plus 2. These two can be combined, so you have 3x squared plus 10x plus 3. Now, let's move everything to one side because to use this formula, one side has to be 0. So we're just going to move the x squared both sides. This x squared, you subtract x squared both sides, so that's gone. Subtract 2 both sides, so this is gone. Now you have 0 on this side. 3 minus 1 is 2. 10x, and then plus 1. Okay, now compare this with this. Basically, you have 2x squared plus 10x plus 1 equal to 0 as your equation. And I can see that to apply this formula, a would be 2, b would be 10, and c would be 1. So we apply this to our equation, to our formula, which is x equals to negative 10 plus minus square root. 10 squared is 100 minus 4 times a times c, so 4 times 2 times 1, all over twice of a, which is 2. Okay, let's continue. Negative 10 plus minus 100 minus 4 times 2 is 8. 100 minus 8 is 92 over 4. Now you still need to simplify, and the way you simplify is by doing the following. You look at the square root and see if there is any square factors. 92 is divisible by 4, right? 4 times 2 is 8. 4 times 3 is 12. So we know that 92 is 4 times 23 over 4. And 4 can come outside the square root as 2. Now see that 10, 2, and 4 are all divisible by 2, so you want to divide all of them by 2. And the resulting formula is you get negative 5 plus minus square root of 23 over 2. So that is the answer. Okay, this time we have quadratic equations. The first one is about numbers. Sum of two numbers is 3. So you have two numbers, let's say x plus y is 3, while sum of squares of these two numbers is 65. So you have x squared plus y squared is 65. And you have to find these two numbers. Okay? When you have more than one unknowns, the way you solve it is first solve for one of the variables. So you take the simpler equation of the two. I think this is simpler than the other one. This one has squares. You take this and solve for y. You subtract x both sides and get y equals to 3 minus x. And then you replace the second number, second y here, by 3 minus x. Because in math, if you have two equal things, you can replace one by the other. Now when you do replace, there's one thing that you have to be careful, which is that when you're replacing a single term by multiple terms like this, 3 minus x, then you need to have a parenthesis. Without the parenthesis, you're going to make a mistake. So y is replaced by 3 minus x as a whole. So we put a parenthesis, put squared equals to 65. And let's see what 3 minus x squared is. 3 minus x squared means 3 minus x times 3 minus x. And again, we do FOIL first, which is 9. Outer, which is negative 3x. Inner, negative 3x. Negative x times negative x, that's positive x squared. Because negative times negative is positive. X times x is x squared. And these two are like terms. Negative 3x are like terms. So you have x squared, negative 3 plus negative 3 is negative 6x plus 9. So that's what you get when you do 3 minus x squared. Since these two are equal, again, we're going to replace this 3 minus x squared by this x squared minus 6x plus 9. So we're going to replace. In math, if two things are equal, you can just replace one by the other. Okay? The resulting expression we get is x squared plus x squared minus 6x plus 9. Again, you see that I'm replacing a single thing by multiple terms, so you need this parenthesis. And then x squared plus x squared is 2x squared minus 6x plus 9. And let's subtract 65 both sides. So this is negative 65 equal to 0. And 65 minus 9 is 56. So this result of this will be negative 56. And you can use the quadratic formula, but that's going to be taking too long. You may try to factor this as it is, but then if you do that, then because this is not 1, you have to do a harder factoring. You have to do factor by grouping or something else. But if you look closely, 2, 6, 56 are all even numbers. So a shortcut would be to divide everything by 2. And what do you get? You get 2x squared divided by 2 is just x squared. 6x divided by 2 is 3. And then 56 divided by 2 is 28. And you can look for two numbers that multiply to negative 28 and adding to negative 3. And I think negative 7 times positive 4 gives you negative 28, whereas negative 7 plus 4 gives you negative 3. Okay. I just did this really quickly, but by trial and error, you'll eventually come to this conclusion. So what does that mean? That means this can be factored as x minus 7 and x plus 4 equal to 0. And that means when two things multiply to 0, either the first one is 0 or the second one is 0. So you get either x equal to 7 and x equals to negative 4. Now, the two numbers are not 7 and negative 4. X was just one of the two numbers. So it's easy to get fooled by your own calculation. So let me back off a little bit and let's see what happened here. So far, we had this system. We solved for y and plugged it in. We got a quadratic equation. We solved it and we got x equal to 7. And also x equals to negative 4. For each case, you'll get a different value of y. What is y? Y is 3 minus x, and in this case, since x is 7, you get 3 minus 7, which is negative 4. Right? So you do end up, well, okay. And then x equals to negative 4, you get y equals to 3 minus negative 4, which is 3 plus 4, which is 7. So here it says the answer is 7 and negative 4. Here it says negative 4 and 7. But these two are essentially the same thing, right? So at the end of the day, it did come out that 7 and negative 4 are the answers. But that was because of some kind of symmetry this equation had. Sometimes if the question was like sum of one number and a double of another number is 3, if you had some non-symmetric situations, then you might have a pair of different answers. Okay, so you have to be careful. Don't think that when you get your x, that's the answer. You have to criticize your own solution and see what you're doing. That's actually pretty important in solving word problems. So the answer would be this right here. Okay, I'll just put red. A right triangle has perimeter equal to 36 centimeters and a hypotenuse of 15. Find the lengths of its two legs. Okay, so you have a right triangle. For geometry questions, it's a must that you draw the picture. Without drawing the picture, it's really hard to solve. Okay, first, the hypotenuse is 15. And I don't know the two legs. That's the question, x and y. Let's just put in x and y. Or maybe, since usually y is the vertical one and x is the horizontal one, let's do it like this, x and y. Now, what is the perimeter of this triangle? Because it says perimeter is 36. Well, perimeter is x plus y plus 15, right? X plus y plus 15. That has to equal to 36. And then that gives you x plus y equals to, if you subtract 15, that gives you 21. Okay, so you have x plus y equals to 21. Okay. We used up all the numbers, right? We used up 36, we used up 15, and it's still asking me to find the length of its two legs. The problem here we're facing is that we only have one equation and we have two unknowns. Well, that means you cannot solve for x or y. We need another equation. So if you have two unknowns, you need two equations. If you have three unknowns, you need three equations, and so on and so on. So we need a second equation. What is that second equation? Well, see, this is a right triangle, and for right triangles we have a very famous formula, which is the Pythagorean Theorem, which says x squared plus y squared equals to 15 squared. And what is 15 squared? That's 225. And then you have a system of equations. X squared plus y squared equals to 225. X plus y is 21. And again, as before, when you have a system, solve for one of the variables, subtract x both sides, so get y equals to 21 minus x, and then plug that into the second equation. And when you plug it into the second equation, make sure that you use the parenthesis. And then x squared plus, if you FOIL this out, well, let's do the FOIL here. 21 minus x times 21 minus x. 21 times 21, that's, let's see, 21. 21, and then 2, 4, that's 441. Okay, good. So 441, then outer, which is negative 21x, inner, which is negative 21x, and last, which is positive x squared. So that's 441. Combine these two like terms, then you get negative 42x plus x squared. So that's what this is. So we replace it as 441 minus 42x plus x squared equals to 225. And then we have x squared plus x squared minus 42x plus 441, and subtract 225 both sides to equal to 0. X squared plus x squared is 2x squared minus 42x. Let's see, what's 441 minus 225? Subtract 1 minus 5 gives you 6. You have to borrow. 3 minus 2 is 1. And then you have 4 minus 2, which is 2. So you have plus 216 equal to 0. Since everything is divisible by 2, again, divide everything by 2. You get 42 divided by 2 is negative 21. 216 divided by 2 is 108 equal to 0. Oh, well, 108 is quite a big number and has many factors. So let's think about something. But they have to add up to 21. And the two numbers have to be negatives. So you need something relatively small that multiplies to 108. So let's see. For example, you have 12 times 9. 12 times 9 gives you 108, right? Oh, actually that does work. 12 times 9 is 108. 12 plus 9 is 21. All right. So I got lucky, but you may have to calculate for a while to get those numbers. So this ends up being factored as x minus 12 times x minus 9 equal to 0. So either x is 12 or x is 9. And for each one of them, again, this is symmetric like the question that we just solved. So if you get the y value by doing 21 minus x, you're going to see that y is 21 minus 12 gives you 9. Here, if you do 21 minus 9 gives you 12. So the two legs are 9 and 12. The answer to this is, I'll write the answer here. It's 9 centimeters and 12 centimeters. Okay, solve two of the following questions. So we have 3 questions that are a little more challenging than regular equations. Let's try them. First is a equation with fractions. Whenever you have fractions, try to multiply to get rid of all the denominators. But before I do that, see this x squared minus 2x? You can factor that, and that will help us a little bit. This is negative 2x minus 2 times x. And you see that if you multiply the entire thing by x minus 2, then this is going to go away because they're going to be canceled. This times this will cancel the x minus 2, so that denominator will go away. This times this one, when you cancel the x's, that x denominator will go away. So you won't have any fractions whatsoever. And that's the strategy for solving any equation with fractions. I've seen some of you trying to do this without doing this step, but that makes the equation very challenging to solve. So it's better if you do it this way. Okay, so x times x minus 2, 5 over x, x times x minus 2, negative 2 over x minus 2 times x, x times x minus 2. See what I did? I multiplied x times x minus 2 to every term that you see here. This x minus 2 will cancel. X and x will cancel, and both of them will cancel. And the result is that you have x times x minus 3, 5 times x minus 2, and then equals to negative 2. And that's relatively easy to solve. X times x is x squared. X times negative 3 is negative 3x, plus 5x minus 10 equals to negative 2. These are like terms, so we combine x squared plus 2x. And if you move the negative 2 to the other side, it becomes plus 2. Negative 10 plus 2 is negative 8, equal to 0. Now, how do you factor this? This can be factored as, well, two numbers that multiply to negative 8 and adds to positive 2 are positive 4 and negative 2. And these two numbers add to 2, and they multiply to negative 8. So we know that this thing gets factored as x plus 4, x minus 2. So you get x equals to negative 4 and positive 2. However, if you have an equation with a fraction or sometimes square root, those equations have something called extraneous solutions. Okay. So you really need to plug these numbers to see if it's a bogus solution. Right? Now, a small tip is if you have a fraction, then as long as these numbers don't make the denominator equal to 0, then it won't be an extraneous solution. See, negative 4 doesn't make any of these denominators to 0, so that's okay. But 2, think about this. What's 2 minus 2? That's 0, right? So that's a no-no. This will be an extraneous solution because it will make this denominator equal to 0, so it can't be a solution. Right? So the final answer that you have here is that x equals to negative 4. Second question here, you have square roots in both sides. We can get rid of the square root by squaring. And one thing that you have to be careful about is you're not allowed to square like this. That's not true. If, say 5 equals to 3 plus 2, but 5 squared is not the same as 3 squared plus 2 squared. They're simply different. So that's not allowed, sadly. Your only choice, your only possible method for solving this is to square the entire thing. That's allowed. Okay. If two things are equal, their squares will be equal, so we just square both sides. This 2 and square roots, they cancel, and you get 2x plus 3. This one, you can't distribute 2 to each individual ones because there's a plus. If it was a multiplication, you can do that, but you can't do that. So what you need to do is you have to actually write it out and actually FOIL it. So that takes a while. 2 times 2 is 4. So first, outer, that's twice of square root of x minus 2. Then inner, that's again twice of square root of x minus 2, and then square root of x minus 2 times square root of x minus 2, which is square root of x minus 2 squared. So that's really this squared. Okay, these two terms are like terms, so you can combine them. So it's 4 plus 4 square root of x minus 2. And this square will cancel the square root there. So you're going to get x minus 2. And the left side is still 2x plus 3. So sadly, after doing all this work, you see that the square root is still there. And that means you have to do another square. But before that, you want to isolate this square root so we can square to get rid of the square root. So let's move the 4 this side, also move the x this side, also move the negative 2 that side. Remember, whenever you move a term, the sign becomes the opposite. So instead of positive 4, it becomes negative 4. Instead of positive x, that's minus x. Instead of negative 2, it's plus 2. 2x minus x, that's just x. 3 minus 4 is negative 1. Negative 1 plus 2 is positive 1. Equals to 4 times square root of x minus 2. Now, to get rid of this square root, again, we square both sides. Okay, so let's move up here. X plus 1 squared. What is x plus 1 squared? X plus 1 squared is x plus 1 times x plus 1. And that's x times x, which is x squared. X times 1, which is x. 1 times x, which is x. 1 times 1, which is 1. So it's x squared plus 2x plus 1. That's a little messy. 2x plus 1. And using this, we can rewrite the left side as x squared plus 2x plus 1 equals to. Now this one, because this 4 times square root of x minus 2, this is a multiplication. This 2 does distribute. You have to know when you can distribute and when you can't. When it's a plus, you can't. When it's a multiplication, you can distribute this power to both of them. Okay, so you have 4 squared and square root of x minus 2 squared, and as before, square root is cancelled by the squared. So this is what you get. You get x squared plus 2x plus 1 equal to 16 times x minus 2. Don't forget this parenthesis. Forgetting this would be devastating because you did all this hard work and you'll make a mistake because you forgot this parenthesis. Alright, you have x squared plus 2x plus 1 equals to 16x minus 32. Move all the terms, so you have x squared plus 2x plus 1 minus 16x plus 32 equal to 0. 2x minus 16, that's negative 14x. 1 plus 32, that's plus 33 equal to 0. Well, 33 is just 3 times 11, right? So if you think about two numbers that multiply to 33 and add to 14, that's 3 and 11. 3 plus 11 is 14. 3 times 11 is 33. And because of this negative sign, both has to be negative, so you have x minus 11, x minus 3 as the factor. And each individual ones will give you x equal to 11, x equal to 3. Again, because this is a square root equation, you have to see if any of these solutions are extraneous solutions. So let's try one by one. What happens if you put 3? Let me put a different color. So if x is 3, then we have square root of 2 times 3 plus 3 equals to 2 plus 3 minus 2. 2 times 3 plus 3 is 9. Square root of 9. 3 minus 2 is 1. Square root of 1 is 1. Square root of 9 is 3. 3 is 2 plus 1. That is correct, right? So that's okay. Yes. What about 11? Let's try 11. Square root. 2 times 11 plus 3. and 2 plus square root of 11 minus 2. Let's see, 11 times 2 is 22, 22 plus 3 is 25, so you end up with square root of 25 equal to 2 plus square root of 9. Square root of 9 is 3, 3 plus 2 is 5, and square root of 25 is 5. So indeed it works. So they both work. X equal to 11 does work, x equal to 3 does work, so we see that both are answers. Okay, so as before, to summarize, whenever you have a fraction or a square root, after getting your answer, you have to plug it back in to see if it's a real answer or a fake solution. Fake solutions should be thrown away, and then you should keep the real one. And an extra tip for fractions is that as long as, in a fraction equation, as long as the denominator is non-zero, your solution will be an actual real solution. Okay, I believe this is, oh, we have another set. Okay, so we're still pretty close to the end. Okay, all right, C, this is an equation that looks really hard, but if you look closely, x plus 7 4/3 and x plus 7 2/3 have something in common. They look almost the same, right? The only difference is this 2 and 4. Now, if you square x plus 7 2/3, then the rule with exponents is that if you have a to the m to the nth power, these two multiply, so you have a to the m times n. So you get 2 times 2/3, which is x plus 7 to the 4/3. And therefore it's the same thing. So these two are equal. So what's so good about it? Well, this is a lovely example where you can use substitution to solve. So this equation itself looks very hard, but for a moment, let's say this is y, or yeah, I guess you can use u. I think a lot of people, many people use u as a substitution variable. Some people use y. Sometimes t is another one. Okay, let's go with u. U is equal to x plus 7 to the 2/3 power. Then we can replace that by u, so we have minus 5u. And then here, this is, as we see here, x plus 7 to the 4/3 is u squared. So you have u squared. And that is just the quadratic equation which you can factor. It factors as u minus 4, u minus 1 equal to 0. So either u is 4 or u is 1. Now in that case, since u is x plus 7 to 2/3 power, you have to revert to your u equal to x plus 7 2/3 power, and solve each individually. So you have this case, and also x plus 7 2/3 equal to 1. So we can solve these separately. Alright, now the way you solve this is by knowing that, well, let me just copy this one more time. You have x plus 7 2/3 power. Knowing that the reciprocal of 2/3 is 3 over 2, and when you multiply them it's just 1, so they cancel, we're just going to take 3 over 2 power both sides. Okay, and again using this formula that a to the m parenthesis n is same as a to the m times n, these two values multiply, and multiplying them gives you 1, so you have x plus 7 to first power equal to 4 to the 3/2 power. Now what is 4 to the 3/2 power? See, 4 is 2 squared. And since there's a over 2 here and that's a 2, you can multiply them, and the 2 and denominator 2 cancels, and you get 2 to the 3rd power, which is 8. 2 to the third power means 2 times 2 times 2. That gives you 8. So you end up with the right side being 8, the left side being x plus 7. Subtracting 7 both sides, you get x equal to 1 as your answer for the first one. The second one, we're going to do the same thing. X plus 7 2/3 to the power of 3 over 2. Now 1 to any power is 1. 1 to the 100th power is 1. 1 to the 1000th power is 1. 1 to any power is 1, so that's just 1. This here, they cancel, so you have x plus 7 equals to 1. So you get x equal to negative 6 if you subtract. However, there's we should plug this in, each individual ones, and see if it works. So if you plug in 1 plus 7 is 8. What is 8 to the 4/3 power? So here's our check. Okay. If you plug in 1, you get 8 to the 4/3 power minus 5 times 8 to the 2/3 power plus 4. And we know that 8 is 2 to the 3rd power. 2 to the 3rd power. And again, we use the fact that they multiply. 3 times 4/3, 3 and denominator 3 cancels, and you get 2 to the 4th power. And then minus 5, 2 to the 2nd power, plus 4. That's 16. That's 20 plus 4. So 16 minus 20 plus 4 is indeed 0. So this does work. Okay, so x equal to 8 is indeed a solution. X equal to 1. 1 is indeed a solution. X equal to 1. And also you can check for x equals to negative 6. That's even easier, because if x is negative 6, this is just 1. So you end up with, for x equal to negative 6, you get 1 to some power is always 1 minus 5 times 1 plus 4. And 1 minus 5 plus 4 is indeed 0. So that does work. Okay, so the final answer for this, let me just write it here. Answer is x equals to 1 and negative 6. Okay, so this is the last problem set. Just 2 questions. First is the quadratic inequality. So we subtract everything to one side. Subtract 4x minus 40 bigger than 0. And you get x squared plus 3x minus 40 bigger than 0. Now, what we do for any quadratic inequality, or pretty much most of the inequality that you work with, you want to use equation rather than inequalities. Inequalities are 10 times harder than solving equality. So what we're going to do is, the approach that we will take is always change an inequality into an equality and see if you can solve that, and then you start from there, see what conclusions you can draw from there. Okay, this is 4 times 10, no, 2 times 10, 8 and 5. Okay, 8 and 5. So 8 times 5 is 40, and positive 8 and negative 5 gives you 3. 8 times negative 5 gives you negative 40. Okay, so you get those two numbers, so you can factor this as x minus 5 and x plus 8 equal to 0, which gives you that x equal to 5 and x equals to negative 8. Okay, so that's the solution of your equality. But what does that mean? Well, it means the following. At negative 5 and at 8, this is 0. And this function here can never be 0 other than at negative 5 and 8. So you have three places. You have this interval before -5. Another interval is -5 to 8. And then the third interval is 8 to infinity. You have three intervals here. And in these three intervals, either this function is positive or negative. We don't know. So what do? You just pick a sample point and just test it out. So here, -6 is here. You know, sometimes something that has 10 in there, it's easy to do. So let's just say here is -10. So pick -10, plug that in. If that comes out as positive, then the entire interval is going to be positive. If that comes out negative, then the entire interval is negative. 0 is my favorite number. It's so easy to compute, so I'm going to pick 0 here, and then I'm going to pick 10 here, because 10 is also easy to compute. Alright, for -10, let's see, x equals to -10. -10 squared is positive 10 squared, because negative goes away if you square it. 10 squared is 100, so you get 100. And then 3 times -10 minus 40, so that's going to be 100 minus 30 minus 40, which is positive 30. So that's a positive. It's a plus, right? That's a plus. When you plug in 0, well, 0 squared is 0. 3 times 0 is 0 minus 40. That's just -40, and that's negative. So that's negative here. When you plug in positive 10, 10 squared is 100. 3 times 10 minus 40. So again, that's 130 minus 40, which is 90, and that's plus. So it's a plus here. Now, what are we looking for? The inequality that we want to satisfy is this being positive, is bigger than 0. So it's we identify that it's this interval and this interval which does work. Now, you want to write down the answer in interval notation. So the first interval is from -infinity up till -5. The second interval is from 8 to infinity, and if you have more than one interval, you put union there. So that's the final answer. That's the final answer. Okay, second one, you have this absolute value inequality. And before we do that, let me just do a quick review of absolute value equality. If you have absolute value of x equal to 1, what x satisfy that? Well, if you have 1, absolute value of 1 is 1, so 1 is definitely a solution. But if you plug in -1, absolute value of -1 is also positive 1, so you have also -1. In other words, if you have absolute value of x equals to some value a, then the solution is a and also -a. In other words, you want plus or minus a. That's what the solution is. Okay, so keep this in mind. Again, we're going to work with the same principle that we want to work with equality rather than inequality. So set this equal to 5/6 and see what conclusions we can come up with. Okay, we're going to apply this. When you take away the absolute value sign, you end up with plus or minus of that number. So that's the first thing. And I see fractions. I just hate fractions. I just want to get rid of the denominator as much as we can. And I see that if I multiply by 6, this 6 will go away, and 6/3 is 2, so this 3 will also go away. So I like that. Let's multiply by 6 to get rid of the denominators. So do this before you do anything else. It's really time-consuming trying to work with fractions, so just get rid of the denominator as much as you can, okay? 6 times 2/3 x minus 6 times 1 equals to plus minus 5/6 times 6. I multiply 6 to all the terms I see here. 6/3 is 2. 2 times 2 is 4, so you have 4x minus 6 equals to 6 cancels at plus or minus 5. So what is that? That means 4x is, if you add 6 both sides, it's 6 plus minus 5, and divide by 4 both sides, and you get x equals to 6 plus minus 5 divided by 4. Now, plus minus means you add ones and then subtract ones. So this is actually two numbers. The first number is 6 plus 5 over 4, which is 11 over 4. The second number is 6 minus 5 over 4, which is 1 over 4. So you have these two numbers. And again, you draw the number line. You have 1/4, and you have 11 over 4. Okay. Now, what do these numbers mean? These are the numbers where this equal sign happens. All the other places, either this side is strictly less or this side is strictly bigger. So if you know that, then we can just start doing sample points. So 0 is a number before 1/4. In between, we'll choose 1. 1 is slightly bigger than 1/4. And here, I'll just choose, I was going to say 10, but 10 divided by 3, that's not a good number. So let's pick something like, let's see, 3. 11 over 4 is less than 3, right? So we'll pick 3. Okay. So for each one of them, we'll test it out. X equal to 0. What happens? If you plug in 0, absolute value of -1 less or equals to 5 over 6. Is this true? Absolute value of -1 is positive 1. Is 1 less or equal to 5 over 6? No. So that's a no-no. That's no good. Okay. So that's a no-no. Then x equal to 1. Let's see. Absolute value of 2/3 times 1 minus 1 less or equals to 5 over 6. Let's see. 2/3 times 1 is 2/3. 2/3 minus 1 is -1/3. And -1/3 absolute value is +1/3. Is 1/3 less or equal to 5 over 6? And yes, that is correct, right? And then when you plug in 3, you get absolute value of 2/3 times 3 minus 1. 3 cancels. 2 minus 1 is 1. So again, you get 1 less or equal to 5 over 6, which is a no. So these two are no good, and this is good. Yes. Now another thing that's a little different from the previous question is that the previous one had a strict inequality, right? It didn't contain equal case. Here, the equal case is included. That means these endpoints should be included. So the actual set, if you draw it, it's like this. It's the interval between 1/4 to 11 over 4, including the endpoints. So when you write the answer to this, the answer would be 1/4 until 11 over 4, including this left, including the right. And you use square brackets. This is also called the closed bracket. So the closed bracket means the endpoints are included. And the previous question, this one, these round brackets, those are also called open brackets. Open brackets mean the endpoints are not included. Here we don't include it because it's a strict inequality. Here we do include it because it contains equal signs. Alright, so that concludes our review.